Hi everyone, this lesson is for Algebra 2 honor students. This is chapter 7 and 8, section 8.4 and 7.11 for radical equations and word problems with applications, and also word problems with variations as well. This is day 4, so let's get started. By the way, happy birthday, Dr. Seuss. If your class is starting on March 2nd, this is Dr. Seuss's birthday. So he's brought so much to everybody. I just wanted to recognize him. So our learning targets are basically to be given a radical equation, find the solution set, be careful with extraneous solutions. Secondly, given a real world situation, determine what kind of variation function is a reasonable mathematical model, and then find the particular equation for the function, basically predicting values for x and y. So basically what we're starting with is solving radical equations. A radical equation is an equation in which a variable appears under a radical sign. The radical sign, this being the radical sign right here, and the radicand is this value inside. Okay, now remember, this is not the same as a division. This is a radical root, right? A lot of times you're going to see a little lip right there, but a root is not a division sign. So just make sure you be careful with that, because otherwise that would be called the dividend, right? But it's the radicand. So solving radical equations. So our objective is to solve for x. If x is underneath a root, then in order to get it out of that root, you are basically going to square or cube or do something like that, possibly more than one time, in order to get the x out of underneath that root and to solve for it, to find the solution. Remember that what we're really doing is, when I say, there's a 2 here and this quantity being to the 1 power, realistically what this is saying is it's 2x plus 4, that quantity, to the 1/2 power, and that equals 1. So when somebody comes up and they say, hey, I have to square both sides, of course it's an equal sign, so you do have to do the same thing to both sides of the equation. When somebody says, I'm going to square this, the reason for doing that is that they're trying to get this value here to cancel out. And so we would square both sides, these 2's would cancel, and you're left with 2x plus 4, and that equals 1. I'm going to solve for x, and I get 2x is equal to -3, because you're going to subtract 4 from both sides. And then I end up getting x is equal to -3 over 2. I divide by 2. And I get x is equal to -3/2. Now, before I put the answer in solution sets, which you want to put all your answers in, I need to verify that this answer is correct and it works and it's not actually an extraneous solution. Now, an extraneous solution is an answer that doesn't work when you plug it back into the equation. What that means is, yes, absolutely, you're going to have to check every problem. All right, so plugging x back into my equation, let's see, just to check, and you do need to check, we're going to get the square root of 2 times x. Now, x is -3 over 2. Add 4. And if we have the right answer, we're going to get this equal to 1, which let's see. 2's are going to cancel, and they make 1. 1 times -3, still under my root, is -3. Add 4. -3 plus 4 is 1. Square root of 1 is 1. Does that equal 1? Check. Yes, it does. So therefore, the correct answer for this problem or solution is this: x equals -3/2. And you put your answer in a solution set. For this problem here, these two problems, this one right here, you do have options. Options are like this. You can, in order to lose the square root, again, we're going to square both sides. But in order to do that, I can square both sides like this, and then this side like that, or I can move this x over to the other side. So I think that's a better option. I'm definitely not going to do that every time, but I think that in this case it is a better option. So I'm going to move this x to the other side. So what I have then is 3 minus x is equal to the square root of x minus 1. And so now when I square both sides, because it is an equation and you do have to do the same thing to both sides, I'm going to get I'm going to square this. Now remember how to square one of these things, right? You're going to square the first term. Squaring the first term is going to give you 9. Square the last term, which is going to give you positive x squared. Multiply these two terms together. So 3 times negative x is negative 3x. Double that is negative 6x. On the right, when I square this quantity just comes out, and when I square a square root, the 2's and the 1/2 cancels, so I'm left with x minus 1. What I notice about this equation is that it is quadratic, which that means I do need to set it equal to 0. And in doing that, I'm going to move everything over to the left-hand side. So I'm going to put everything in like order. So I have x squared, that's first. When I move this x to the other side, that becomes negative x, so that's now negative 7x. And then when I add 1 to both sides, I end up getting positive 10. So I am going to factor this, and when I factor, I get x minus 5 times the quantity x minus 2, and that equals 0. And then splitting this up, because it is set equal to 0, it is quadratic, I'm going to set both of these equal to 0. So x minus 2 equals 0, so x equals 2. I get x minus 5 equals 0, so x is equal to 5. So realistically, I possibly can have 2 solutions for this problem. And so in having 2 solutions, what I see is plug your values in. So the first value I'm going to plug in is 2. So plugging in 2, I get 3 equals 2 plus the square root of 2 minus 1. Now, 2 minus 1 is 1. The square root of 1 is 1. 2 plus 1 is 3. 3 equals 3. Check, 2 works. Okay. The next one I'm going to plug in is 5. So let's try that one. 3 equals, and I'm plugging this back into the original equation. 3 equals 5 plus the square root of 5 minus 1. The square root of 5 minus 1 is 4. Square root of 4 is 2. 5 plus 2 is 7. 7 does not equal 3. What that means now is that my solution set is not going to include 5. That means 5, while it is an answer, is what we call extraneous. It's an extraneous solution. And so therefore, I'm writing down my answer, and I'm going to show you how you're going to write this correctly, okay? Writing down your answer, this is how you're going to write it. You're going to say x is equal to, you're going to put the number 2 in your solution set. The number 5 is still an answer, but it's not a solution. And so therefore, it makes it extraneous. So because x cannot equal 5. So this is how you would write your answer. And, you definitely can't blue, okay. You can highlight it if that makes you happy or not, but that's how you would write your answer. Your solution is 2, x cannot equal 5, 5 becomes an extraneous solution because it didn't work when we plugged it back into the equation. For this problem here on the right, in order to undo this cube root, now remember, that's going to be x minus 2 to the 1 over third power, right? So this is a quantity, and then this is to the 1 power, so that becomes 1/3, and then that equals 2. So what we're going to do, in order to get rid of this 1/3, we're going to cube it. So we're going to multiply by to the 3rd power. But remember, whatever you do to the left side, you have to do to the right. And so here, these 3's are going to cancel because that's 3, right? 3 over 3, which is 1. And I'm left with x minus 2 equals, and then 2 to the 3rd power is 8. So I'm going to add 2. I get x is equal to 10. So I'm done. However, again, you need to check your solution and make sure that it is not an extraneous solution. So plugging 10 back into the equation, we have the cube root of 10 minus 2. And does that equal 2? So 10 minus 2 is 8. The cube root of 8 is 2. And so 2 does equal 2, check. So we have the correct solution. So therefore, x equals 10 is my solution. I don't have any extraneous answers. That's just my solution. And for those of you who forgot how to do this, I mean, yes, I know your calculator will do this. Your calculator will go 8 to the parenthesis 1 divided by 3 power. Or some of the calculators will just do a cube root like that and you just type it in. The other option is just to actually do this by hand. And remember that 8 is actually 2 to the 3rd power. And then this is to the 1/3 power. 1/3 power, see the 3's cancel, and I end up getting 2. That's how I knew that my answer was 2. And so check. All right, so far so good. This problem here, definitely a little bit trickier. We have x minus 7, the quantity, or the root, and then equals the quantity root x minus 7. I'm just going to leave the values on the same side because it looks kind of even the way it is. I'm going to square both sides. And by squaring both sides, that's going to get rid of this root on the left, and it's going to give me x minus 7. But on the right, remember how you square these terms. Remember, for example, and just on the side, this is not the problem, but just on the side, 2x, let's say, plus 1 or plus 4. The way you would do that if you squared it is you square the first term, so that's going to be 4x squared. Square the last term, so that's plus 16. Multiply these two terms together. So 2x times 4 is 8x, and then double it. So 8 times 8 is 6. 8 times 2 is 16x. So that's how you would do a square, a perfect square like that. So that's what we're going to do, but with the roots, okay? And so we're going to square the first term. So when you square the first term is square a square root, you just get x. We're going to square the last term, which is positive 7, or excuse me, positive 7 times, it's negative 7 times negative 7, which is positive 49. We're going to multiply these two terms together. So negative 7 times root x is negative 7 root x, and then double it. So now it's negative 14 root x. Okay? I'm going to subtract x on both sides. That's actually going to cancel these two out. I'm going to subtract 49 from this side. And when I subtract 49 from that side, I do get negative 56, I believe. So subtract 49, move it to the other side, I get negative 56, and that equals negative 14 root x. And then 56 divided by 14, I'm going to divide by negative 14 on both sides, and the negatives are going to cancel. I'm going to end up getting the square root of x is equal to 4, because 14 times 4, 14 times 4 is 56. So that's where that 4 came from. Now, again, my objective is to solve for x, but I can't solve for x if it's under a root. So again, I'm going to have to square both sides. And by doing that, I get x is equal to 16. Now, before I put my answer in solution sets, I do need to check my work again. Definitely always check. Okay, so plugging in 16, we're going to get the square root of 16 minus 7. Does that equal the square root of 16 minus 7? Square root of 16 minus 7 is 9. Square root of 9 is 3. And then here, the square root of 16 is 4. 4 minus 7 is negative 3. Does negative 3 equal 3? No. So therefore, square root of 16 becomes a not. It cannot equal that. So what that means, so therefore, for my x value, I have no solution, and then my extraneous answer is 16. Now, you can leave your answer like this right here, or you can actually put in a no solution like that. You can either leave it as an empty set, meaning there's no solution that worked out for this problem, with 16 being an answer, but extraneous. So extraneous actually is spelled extraneous, like that. So you would say no solution, but you do need to show that you did get 16 as an answer, but it's just not a solution because when you plugged it back in, it didn't work. So solving for this problem here. So again, you have options. Option A is to square both sides like this. And by doing that, I'm going to show you, like, I'm going to start this out. And then by doing that, if I square the first, like, you know, you're going to have to FOIL that. And also this side here, right? You just square that. You're going to square the first term. That's going to be x plus 4. You're going to square the last term, and that becomes x minus 4. But in the middle, what's going to happen is you're going to have to multiply these two terms together and then double it. So realistically, I'm going to have 2 times this whole term in here that I'm going to double. All right. So that's going to be x plus 4 times x minus 4, which you should know, right? Difference of 2 squares. We get that. And that's equal to 16. So what I do now is I would have to work this out all over, you know, just keep working. And so I've got x plus x. So I've got 2 x's. It does look like my 4's are going to cancel. I still have plus 2 times this quantity, which I'm just going to change to be x squared minus 16. And then this equals 16. So I've got 1x and 1x. So that was my 2x. I still have this 2 here because it was doubled, right? 16. So now I'm actually going to subtract 2x from both sides. So I have 2 times the quantity. X squared minus 16 is equal to 16 minus 2x. I do see a 2 here that I can cancel. Like I'm going to divide the whole quantity by 2. And in doing that, I now have the square root of x squared minus 16 equals 8 minus x. And I still am trying to solve for x, but this x happens to be underneath this root. So again, I do need to square this one more time. And by squaring that, right, I am going to lose this root, and I'm going to get x squared minus 16 equals, now this 8 is going to be, right, square the first term, I get 8 squared. Square the last term, that becomes plus x squared. Multiply these two together, I get negative 8x, double that, negative 16x. And at this point, what I need to do is combine my it does look like my x squareds are going to cancel. So those are gone. I'm going to move this 16x over to the other side and make it positive. So I have 16x equals, and then I'm going to add 16 to both sides, just the 16. And what is that going to be? 80. And lastly, I'm going to divide by 16 on both sides. And in doing that, I get x equals 5. Now, before I do anything with the 5, right, I do need to check my answer. So I'm going to go back up to the very top, and I'm going to plug my answer back into the equation to check. So in plugging 5 in, right, I'm going to get 5 plus 4. Oh, that's 9. 5 plus 4 is 9. And then plus 5 minus 4, which is 1. So plus the square root of 1. Does that equal 4? So I have 3 plus 1 does equal 4. Check. So what that means is that my answer that I did get, my 5 way down here, is actually my solution. And that also means that I don't have any extraneous solution. So my answer is 5, not negative 5. I know it looks like a little bit of a negative there, but let me rewrite that. So my answer, x equals, put that in solution set, which is 5. And for those of you who are super big box people, box the answer with the solution set in it, okay, because that's what you would do. Now, I wanted to do this one more time. And the reason for that is just because I like math. No, the reason that we wanted to do this one more time is because I wanted to show you another way of doing this problem other than the way we just did. So the other way that I would show you is to take this root x minus 4 and move it to the other side of the equation. And in doing that, I get the square root of x plus 4, and then that equals 4 minus the square root of x minus 4. And so now, yes, I am going to square both sides to try to get rid of the roots that I can. I am going to get rid of this root on the left, because when you square a square root, again, that root goes away. It's a half power. You square a half power, it's 1. So we have x plus 4 on the left. On the right, we are going to use the shortcut method again. Square the first term, which is 16. Square the last term. Negative times negative is positive, so that'll be positive x minus 4. And then we're going to multiply these two terms together. So negative 4 times the 1 is negative 4. Double that, that becomes negative 8 times the square root of x minus 4. So now I am going to, actually, x's are going to cancel. This negative 4, I'm going to add 4 to both sides, and I'm going to get 8 is equal to 16 minus 8 times the square root of x minus 4. I'm going to subtract 16 because this 8 is still attached. My goal is to get one term and one term. So I'm going to subtract 16. So if I subtract 16 from both sides, I get negative 8 is equal to negative 8 times the square root of x minus 4. And then the only way I can get rid of this negative 8, which is in front of the root, is to divide by negative 8. And by doing that, this becomes 1 times the square root of x minus 4. And negative 8 divided by negative 8 is 1. And so lastly, what I need to do is I need to square both sides to get rid of this root one more time. And in doing that, I get x minus 4 is equal to 1 and x equals 5. So again, of course, I would double check my answer, but since we just plugged that into the equation on the other page, I actually don't have to do that again, right? And so this for me is just an opportunity for you to experience two different ways of doing this problem, right? In this problem, we did this where we kept the values on the left, right? And I squared this term on the left, and then I squared this term on the right, and then I multiplied that out. However, is that any better than moving this term here to the right-hand side? That's up to you. It's a personal preference. You decide what makes more sense to you, and then you do that, okay? So we're going to conclude with some variation problems. And a variation, if you recall, when we were working with exponents, we did some variation problems. Remember the multiply property? That's what the variation was. So we're going to talk about this right here, which talks about if the constant is multiplied by the variable, then y varies directly with the power of x. So y varies directly with the nth power of x. And so when y varies directly with the nth power of x, that means k is constant. This is my constant value. Now, if the constant is divided by the variable, then y varies inversely with the power of x. So the way you would write the inverse of the nth power of x is like this. Okay, so there's two different ways you would write a variation. One, you would say it varies directly, and that's when you're multiplying. And one, you're saying it varies inversely, and that's when you're dividing. Okay, these are some of the equations of the variations that you may experience. So, for example, this one is just y equals kx. That's linear. That's what we've been doing. If that's what you have a line. This is quadratic. It varies directly with the square of a function. If it is cubed, it varies directly with the cube. Now, see, all of these when I'm multiplying straight across, k times x, k times x, k times x, those are all varies directly. However, when I divide by x, now I'm varying inversely. Now I'm varying inversely with the square. So these are the general equations of what we've done, what you've been exposed to so far. So what do they look like? So far, if you are multiplying something, right, that's going to move up super quick. Basically, what you're looking at here is that when you're multiplying the value of x by some number, right? And remember when we had the table where we have x and we have y, and we're saying, well, if I'm adding something here, if I'm adding something here and I'm multiplying something here, right? So what you're doing is you're looking for a pattern. So this is the add multiply. Multiplying the value by some constant causes the same value to be multiplied. This is the multiply property, which is what we're going to do today, which is basically if I have some number, I don't know, like 5, and over here I have 6, okay? Multiplying some number by here, let's say I multiply by 3. If I multiply this number by 3, okay, then multiply property is basically saying I'm going to take this number and also multiply it by 3, but not 3. I'm going to multiply it by 3 maybe squared. So that would be directly, it's a variation, directly with the square. And so there's different options. And so what you need to do is based on whatever table that you are exposed to, you have to see what the pattern is because they're all going to be different. Sometimes you're going to be dividing by that same number, and sometimes you're going to be multiplying because it could very easily be, instead of saying multiplying by 3, I could be dividing by 3, which is basically saying it's it's varying inversely. Okay, so it just depends. You have to look at the pattern. So with the multiply property for this one right here, this is what they're talking about, it being a square. So it's if 1 is multiplied by 3. So we start off with 1. We multiply by 3, we get 3. We multiply by 3, we get 9. We multiply by 3, we get 27. Okay? But on the right-hand side, whatever value we have for y, let's say it's 5, then the next value, I'm actually multiplying by, it looks like 3 here, 9 here, that would be 3 squared. So this would, again, multiply by 9 from here to here, that's another times 3 squared. So that's the multiply property. Whereas this one here on the right is, it looks like I'm multiplying by 3, starting off at 1. I multiply by 3, I get 3. I multiply by 3, I get 9. But on this one, instead of multiply, this one is inverse. So I'm multiplying by its, reciprocal property, which is its inverse. So that's 1 over 3 squared. Okay, and so pending what what table they give you or what values they give you will, depend on, what property you're using or what the general equation is. So for linear functions, you guys are going to have the add property. And so that's when you're adding a constant to x. So we're adding something to this value on the left. You're adding a constant to y. So that's the add property, and use that with linear functions. The add multiply property, which is what we did with exponents, when you have a function and you have some value here, you're adding that value here, but then you're multiplying by a constant on this side. So that's why it's called the add multiply property. Now for today, we are doing property of variations, and this is the multiply property. So multiplying x by a constant, so some value here, you're multiplying that value, multiplies this side here by that value, or whatever that is, let's squared, or cubed, or whatever. You also could be, it could be an inverse too, depending on, again, what the question is. Once you understand, like you have a grasp of these concepts, then, you can definitely do the variation functions. So we're going to start off with just an example. This one is water pressure. And it says the pressure required to force water through a garden hose. And this is our garden hose here. depends on the number of gallons per minute, so that's GPM, you want to flow. By experiment, you find that for a flow of 3 gallons per minute, a pressure of 10 pounds. So we've got 3 gallons per minute. P is, we're going to stand for pressure, so that's 10 pounds. Then it says for 6 gallons per minute, so that's your 6 right here, a pressure of 40 is required. So in this case, what we have the pressure of 40, so we need 40. We have 6 gallons per minute. So what we're going to do is, first, we have to recognize what it is. What kind of a variation is it? So I'm going to multiply 3 times 2, and I'm going to get 3 times 2, which is 6. And in this case, I'm thinking that this one from 10 to 40 is going to be times 4, which is actually 2 squared. So this right here is sort of what I'm looking at right here. But if I want to find a pressure that has a rate of 12 GPM, so that's my 12, which is right here, is that going to work if I go 6 times 2? Now that's 12. See, so I'm multiplying that same value. But on the right, what I'm doing is I'm going to take that 40 and I'm going to multiply it again by 2 squared. And so that's going to be 160. So if it's asking me for the pressure required for a flow rate of 12 gallons per minute, that answer for 12 gallons per minute is going to be 160 PSI, or that's my pressure. So for this problem here, so for part B, it says the pressure required for a flow rate of 4.2 gallons per minute, that's what you're trying to find. To find K, you have to find your equation first. So the only way to find the equation is basically to plug in the points that you have for your gallons and for your pressure. So we're going to plug in 310, which is one of our points, or one of our values. So so for this problem right here, I'm going to say, well, my pressure being 10, so that's going to be 10, is equal to K times 3 squared. So in order to find the value for K, I'm going to go K times 9 is equal to 10. So K is equal to 10 over 9. And so that's my K value. So once I have my K value, I'm going to plug this into my variation. So my variation, I've got, let's see here, we're going to go P is equal to 10 over 9 G squared. So now we have our general equation for this specific problem. Now what they want to know is find the pressure required for a flow rate of 4.2. So that means that I'm going to plug that into my G value, and I'm going to get P is equal to 10 over 9 times 4.2 quantity squared, okay? And so in getting that, I did this on paper. I get P equals 10 over 9 times, let's see, I think it's 17.64. And then I still need to multiply this out, and I end up getting P, let's see, equals to, let's see, multiplying that out, I get P equals 19.6. And so that means that's my pressure when the gallons per minute is 4.2. Okay. Now for this problem, it says find the number of GPM you would use, or you would get, with a pressure of 5. So we have our actual equation. We're going to use that equation to solve the problem. Okay. So that just means I just plug in 5 for P. So I've got P is equal to 10 over 9 G squared. I'm going to multiply by the reciprocal to lose the 10 over 9. And so that's going to be multiplying by 9 over 10. 9 over 10. So that will cancel those values out on the right. and give me G squared is equal to, that's 1, 2, 9/2. And then I'm going to square root both sides. And when I square root both sides, I'm going to get the square root of 9/2 or 4.5. What is that? G is about 2.1213. 2.1213. So that's the gallons per minute. If that's the number of gallons if my pressure is 5. So you just basically are working backwards in this problem. Right? Not terrible. That's not terrible. Here's another one. So for all our swimmers out there, when you swim underwater, the pressure in your ears varies directly. So this is saying, hey, we're varying directly. We're not varying with we're not doing something where it's multiplied, squared, or it's in an inverse. In this problem, we are varying directly with the depth at which you swim. So at 10 feet, the pressure is 4.3. This is just 10, 4.3. All right. And so what you're going to do, and then D being your distance, right, going down. So for this first problem, it just says write the particular equation. So we have to find the equation. This right here is not the actual equation because we have a constant here we don't know. So you're going to plug this value into the equation. You've got P is your 4.3 is equal to K times D, my distance, which is 10, at 10 feet down. And so my constant, or my K, is going to be 4.3 divided by 10, which is going to be, move the decimal over, so what's that, 0.43. So that's K. That's my K value. And so now that I have my K value, I have my equation. It says write the, this is all I had to do, was write the equation. The second part, I'm not sure, what's this? Oh, that's just, I guess, showing you what to do. For this problem, this part B, it says predict the pressure at 50 feet. Well, we have our equation now. You have to have this equation, meaning you have to find K. So in doing this, we're going to go P, or the pressure on your ears, is equal to 0.43 times my distance, which is going to be 50. And I'm going to multiply this out so I get my pressure